So compiler, what we can say, uh, compiler is like it takes the source code and translates into some intermediate code, and that machine works on. An interpreter does one thing less, that it doesn't compiles everything. Now that thing I can only show you with respect to example, with respect to my Python interpreter, because Python is also an interpreted language. But what is the basic difference between compiler and interpreter? Let me show you real life, and then we can work on what is the difference between them. But with respect to Python, I'm telling you. Okay, so my idle. Okay, let me start. Start it. Now what happens? Let me give you a vague idea on that also. Suppose you're working on some system and you have to pass the same thing on the other system. It is working on Windows and that is working on Mac. If you're writing something in compiler here, so compiler will compile the code and make some executable code which is known as byte code. And if you transfer this byte code or compiler code to the different operating system, that thing is not going to work. It is going to fail. Only the executable files can be sent. And for that we need that interpreter. If you from the byte code, actually the next level goes with the interpreter. If you pass the interpreter code to any device, it is a cross platform. You have to have the configuration there also, on the Mac also similar to it. It is going to work. The ultimate motive of the compiler and interpreter is to convert your high level code, your source code, to the machine level code. So suppose, example, you have written something as int a is equal to 10 and char b is equal to hello. This thing, if you convert to your machine code, what will happen? That 10 will be converted to some binary, and the binary version of 10 is how to find it. So it's 10 divided by 2. It goes with 5, 0, then 2, 2, 1, and 2, 1, 0. So 1, 0, 1, 0. 1, 0, 1, 0 is the code for our that 10, only 10 keyword. So that is what machine will understand. And hello, I have to bifurcate further, because for that you have to first understand that ASCII value, but don't go deep. Okay, I don't require those things for you all to switch start the career in Python. It is not now, not necessary. Only if you're going to work as a backend engineer, the backend developer, going much more deeper, you will require to cover these details. As of now, if you're going for some other type of domain, it is not required. So ASCII value have different from that hello. I think from for H it will be 65 plus something, and for these things it will be 42 plus. Just read the ASCII level, and it will be again converted to 0, 1, 1, 0, something like that, because these things have to be converted. So each of the letter will be 8 bytes. I don't know exactly what value. It will be changing the value with respect to the numerical values we have. You can find the numerical value from the ASCII character. Even if you Google it, it is going to show to you. So this is the machine code. Your high level source code is converted to machine code. But if you take the help from the third in-betweener, you're not directly converting. From source code, you're getting the byte code, and then you're going to the machine code. So the byte is the executable file. Somewhere it is similar to that, not exactly. People also refer to it. Both of these, both the source code, because it is a high level, and byte code, it's actually readable. You can read it, but you will not be able to understand the byte code. It is something like encryption it will do, but at the back end, the computer will understand. So similarly, if you have written something like int a is equal to 10, int b is equal to hello, it will be converted to something like a, b, hash, question mark, 3, 4, percentage, hash, similar to something like that. It will be converted some encrypted language, and later on, that thing will be converted to machine code, which is like 0110, 100, something like that to understand. Only machine can understand how it is able to extract from this byte code, this machine code. So this is the intermediate. This is in depth, which is not required for all of you. I'm giving the same thing, how compiler and interpreter differentiates. I'm not going to cover these things, how the codes are generated from source code to byte code and byte code to machine code. Machine code to even I don't know how it is going to make. It is done at the back end. I cannot help you with that. So I'm sharing the whole screen. Okay.
Mukesh, can you just repeat the difference between compiler and interpreter?
Just now let me show you the example. Actually, compiler interpreter I have not shown there. I've just shown there how the source code is converted to the byte code and byte code to your machine code. So how code are changed, but how they are working I have not shown you. So on the left side, that is your main window. This is also a Python IDE. IDE is that development platform where you are working. So development environment. You don't have to install this one. This is also the Python software. And on the right side, it is like similar to interpreter. Now the compiler, what it do, in Python, I'm writing the code that a is equal to 10 and some b is equal to hello. I'm printing my a and print b. I have to first save this also. Let me save this on the desktop. Now what happens? The compiler first save the whole code and then it executes it. What happened now? If I run this one, the exact all 4 lines will be first compiled. Something will happen at the back end, and now on the outside, it is going to execute all the lines at a single time. At a single time, okay? So I'm running it, and on the right side, you can see whatever conditions I've written on the left side, everything is run simultaneously on the right side. That is the compiler function. Now what the interpreter does? It both the compiler and interpreter does one thing: convert your high level to the low level. How they do it, the functionality differs, and it of course depends on the project. Compiler first understand all the things, all the lines of codes. If there is any error, it is going to pop, and if there is no error, that is going to compile it and then run all the commands simultaneously. In interpreter, you run one line at a time. How? For example, here also I write a is equal to 10. I press enter. You can see triple greater sign has sign come up. So this means only single line is executed. Now the moment I have pressed enter, next line came up. So the level of a is stored at the backend. If I write a here, again I press enter, you can see the output of a. If I write a is equal to, this time let's change the value, and what the latest value that you give, it will be updated. Now I'm giving a is equal to 15. Even I press enter, so it is not allowing me to write the second line. You can see triple greater than sign came up. So interpreter only runs one line at a time, and the interpreter in Python is none other than PVM, Python virtual machine. This is the full form for this. Okay, let me run it. Don't worry about the error what came up. And if I write b is equal to world here, so hello world will be combined, I think. Even if I run this, action has been done, a single line has been executed. I write b here, world has been printed out. So it is actually executing single line at a time. I write print A here, 15, what is the value above came up, and print B here, this word. So interpreter is actually helping you to run only one line at a time. But Python, that compiler, it saves everything and then run all the lines simultaneously. So that is the basic difference between compiler and interpreter. Both the things are same. It converts your high level language to low level language. I'm writing Python on the left side also, Python on the right side also. That is my high level. Machine learning, I don't, machine code, I don't know what they have written. That is the headache of my system to understand, but I have written for myself. Yes, better.
So in an interpreter, you kept changing A and B and you took the recent value, right? Here
Yes.
in a compiler, you gave only one value. What if you've given two values? How will it compile, like how you did for interpreter?
Actually, that was
Like A
not
is
that.
10, B is hello. Probably you give another A is 15 and
If I
B
write
is
A
12.
equal 15, last value will be taken. You can see here. Now 15 is there and hello is printed as per print A and print B. Print is the function that displays the variable on the output screen. So that is my output screen here. But updating the value, we will discuss that thing later on. The point was that compiler will first take input of all the lines. It will check it out whether each line is getting the error or not. If it is getting the error, it will stop there. I will show you that thing also. If I write something here, okay, I'm just writing some logic. Don't worry about the logic. For I in range 1 to 10, print I. What it do? Let's see that thing. Okay, just see that thing. I'm just closing it. I'm freshly starting. Running it. Something came up on the outside. You can see here. It compiled both the lines, run and understood what will be the output, and it has not got any error. So for that reason, the output was displayed. Now what will happen? If I just close it, I include an error here. Now you can see I need some bracket to get my I. If I don't get my bracket here, what will happen? You can see before going to the showing the output on the next screen, nothing is shown. Why? There is an error. So you have to take care of the error first. Even because as per the functionality, what will happen? Most of the languages are top-down approach. So if the first line is correct, it should have displayed something. I write something as let's say print. Directly I'm writing here hello world. If I delete this thing and print it, you can see hello world is printed. So that line is correct for me. Okay. If I write something here, after this I write something. So first line should be printed out. But if I do it, you can see here, I'm getting the error. So that is another advantage of compiler, because it is actually understanding all the lines and then it is performing the action. In those lines, if it gets the error, it is going to stop right there. It will not go to the output screen. But in my interpreter, wherever I get the debugging is easy. That is catching the error is easy. If I write same thing here, print hi all, you can see output is printed. Now I'm just using the same thing for I in range 1 to 10. I write print I. And the output has been printed out. Same I write something as with respect to error 1 till 10, print I. Okay, that line will not be printed out. So my mistake, that's not the point. Actually, I wanted to just highlight the point that first line here is printed out and the second line is not printed out in the compiler because they are combining all the lines and trying to understand the code. In the interpreter, the first line what I have written is not giving the error as it is correct, but the next thing that I have written was having the error. So take it as two parts. First part printing hello world, second part displaying the numbers. On the interpreter also, first part printing hi all worked, but second part printing all the numbers haven't worked for me. So this is like I can catch it, I can debug it because I can see it is working at one line at a time. So I was able to catch it that in this particular line I definitely have the error. But in my compiler I have to study where I have got the error. So that is the difference between your compiler and your interpreter. Now think of something like you're a happy human being and you write only high level languages, and there is a system which understand only machine level languages. You have a robot here. Okay, I'm just making that robot arms and super body. This robot actually helps you to give this instruction. It will convert whatever you are saying to the machine. So you write one line of code, it will translate to something ABC, and the machine will understand that this is what I'm going to execute. Again, you write something as print hi. It is going to change it to something like this, and machine will understand, it is going to execute. But the moment you write something else, and you can see the interpreter is solving it faster. The moment you have written something, the robot is changing and converting to machine. But at the time when you're printing the next line, what happens? If I write something as 10 plus 20, I would like to sum it up. It is going to add something, and something would be done here, 10. At the time when human is writing something, the machine is vacant. So it is fast because you are directly converting to the robot is directly converting your single line at a time. That is fast, but the machine is vacant at that time. It is going to execute at all. And the last line, if you write something with the respect to error, that again I'm writing something as print. I'm not giving any brackets here, and I write 10. The interpreter is going to say error. It has received the error at the same moment. What you have also seen, how I have received the error the moment it has understood that I was not having the brackets. It gave me the error, and machine is vacant now. So this is the first case in which you are working with the interpreter directly. Now the opposite of it, same scenario. You don't want to waste the time now. You want like the machine should write the code with respect to it, and the robot will actually convert everything in one go. And then whatever the task is, it will going to perform it simultaneously. And you have written something here also, int a is equal to 10, print 100, it is going to print 100. And if I write something as 10 plus 20, and here also write print hi in proper formats. If the format is okay, now I send everything to the robot. This happy robot, we convert everything with respect to the code what you have seen. Something hash a b c 10, something like that. It is going to convert to you, and machine will understand what the robot has written to me and is going to perform all the commands simultaneously. So here only the compilation time is added. Only the time what you have written, the compiler will take the time to understand what you have written in the code. If it is correct, everything will be passed on to the interpreter, and it is going to convert, and then action will perform. But if anywhere it gets some error, that you have written something like that, you have opened the bracket but you haven't closed it. Now while it is executing all the commands simultaneously, the compiler is performing the actions here. It found that there is an error. It is going to stop right there, and you have to correct it before you go to your before robot will change your code to the machine level of code. So this is the basic difference between the compiler and interpreter. Interpreter is fast because it is executing the line the moment you have written, in that aspect only. But once the compilation has been done, it has understood every logic of your program, it is going to take less time. Only the compilation time is added, but the time will be saving a lot of your time. The robot task was to convert your high level to low level. That's what the task is all about. So even if you write on your compiler or on your interpreter, both the commands do one thing only. They convert your high level to your low level. That is the basic motive. The only differentiates is the functioning. In interpreter, it works one line at a time, but in our the compiler, it executes all the commands that it has written and send it simultaneously.